Okay. A and B are two sets having 3 and 6 elements.
6 elements respectively, yeah.
Hmm.
What is the minimum number of elements in A union B?
Minimum number of elements in A union B. So before you can do this question, obviously you need to understand what the notion of what is a set. Set is a collection of elements, right? Some
Okay.
A, B, C, D, E,
Mm.
F, G, right? So
Yes.
any collection of elements is a set of those things, right? So a set of
Correct.
numbers would be some set of numbers, right? So
Yes.
set of fans, set of books, whatever, right? So set can
Yes.
basically encompass anything. And now you have these sets. Now A union B means A or B. So if A union B set you want to write, then A union B means all the elements which are either in A or in B. So I will write A, B, C, D, E, F, G. This is the new set which is A or B. Either they are
Okay.
in A or they are in B. A
Okay.
intersection B would be, they have to be in A and B. Okay.
Okay.
So
Okay.
A intersection B will be a new set which will be elements which are in both of the sets, right? So in
Yes.
this case, in our particular case that we are looking at right now, it will be null set. Basically, nothing is in both, no? There is no
Yes. Yes.
common element, right?
There's no common. Yeah.
So this is a null set. A null set is a set with nothing inside. Null set
Nothing.
is
Yeah.
just has nothing, right?
Okay.
So we have notions of cardinality of a set. Cardinality of a set is the number of elements in a set, right? So in this set,
Yes.
cardinality is 4. In this set, cardinality is 3, right? Na is equal to 4. N of B is equal to 3. Cardinality of a null set is denoted by the symbol phi, is 0, right?
Okay. Okay.
There is
Yes.
nothing inside a null set. Null set can be written as phi, okay?
Okay.
Also, we have a simple identity which is n of A plus n of B, right? Should be n of A union B plus n of A intersection B. Wait, are you sure that this is correct? Wait, one thing that I'm sure of is n of A intersection B, is correct, is equal to n of A plus n of B minus n of A intersection B. So this is the
Okay.
same thing. If you bring it to this side, this is this equation, right? So
Yes. Yes.
let's try to understand how this makes sense. So what is the meaning of n of this? N of this means number of elements of this.
Yes.
N of A means number of elements of A. N of A union B means number of elements of A union B, and so on, right?
Yes.
So now,
Yes.
if you draw a simple diagram, a Venn diagram it is called, named after the English mathematician John Venn. So Venn
Okay.
diagrams are a nice way to represent sets. So suppose you have A and you have a B, right? A and B, right? And this number of elements that are in A has all of these elements, right? Now
Yes.
some of them are in both of them, right? Suppose these three, right,
The common.
are in both of them. Some of them are in here only, and some of them are here only, right? And some of them could be
Yes.
outside also,
So
correct?
doesn't belong to anything. Yeah.
Don't belong to either A or B, right?
Okay.
Correct.
Yes.
So
Yes.
if you think about A union B means A or B, right? Then A
Yeah.
union B will be anything in A is fine, anything in B is fine. These are also fine, no? These belong to
Yeah.
both of them, right? So it is definitely in N of A union B, right? So
Yes. Yes.
think of this, A union B can be written as A plus B minus A intersection B. Why? Because if you think
They
of
are double.
these elements, right, these ones, right, they come
Yes.
once, then this one comes once in A, right? A has these ones plus these ones, right?
Yeah.
B
Yes.
has these ones and these ones again, right?
Yeah.
So
So it's
so
coming.
so it is coming two times, so you have to exclude it once, right?
Oh,
That will be the whole thing, right?
yes, I
You understand?
understand.
So n of
Yes.
A union B will be equal to n of A plus n of B minus n of A intersection B, right?
Okay. Yeah.
So, okay.
Understood.
So in our question, A was 3 and B
Hmm.
was 6, right?
Yeah.
And you are going to ask, you're being asked to say something about A union B, right?
Yeah. So it's
This
below.
will be equal to 3 plus 6 minus n of A intersection B, right?
Yeah.
N of A union B will be equal to 9 minus n of A intersection B, right?
Yeah.
Now, what was the question saying? Find the
Minimum number of elements in A union B.
minimum number of elements in A union B will happen when this is lowest, right? This is
Yeah.
lowest when this is maximum, maximum.
Yes.
This is maximum
Maximum.
when A, all three elements of 3 are common to this, right?
Yeah. Yeah.
So 9 minus 3 is the maximum that can happen, no? It could be like this. A is like this and B is like this. All the elements of
Yeah.
A are already in B, right?
B. Okay. Okay.
Then that
I
will be
understand.
6.
Yes.
Maximum number could be 9, no?
Maximum is all of.
Like none of them are common.
Yes. Yes.
Then maximum will be 9. No, nothing is
So
common. Then A union B will be just this plus this, right?
this. Yes. I understand.
Okay. Minimum
Okay.
is this. So this is something, this is a basic law. There are other laws also, De Morgan's laws in set theory. But it's fine. Like we'll come to that when we need to. Like
Okay.
you should just find out on there is a website called brilliant.com. You should just go to the brilliant.com, just check it out, and in that you can go to set theory. They will explain everything nicely. Go to set
Okay.
theory section, just learn a little bit of basics of set theory because it will be useful throughout maths. Set theory is like the fundamentals of all maths now. So
Okay.
in the 1800s and all, calculus and
Mhm.
everything was being developed, and eventually all of maths was unified under set theory. So in the late 1880s and 1900s, set theory became the fundamental basis on which everything was built upon. So you
Okay.
might as well figure out a little bit of basics, like at least De Morgan's laws and all you should figure out. So go to either Khan
Okay.
Academy or Brilliant or somewhere, right?
Okay.
Okay, next.
And there is another question on set theory.
Hmm.
If x equals to
Hmm.
a, b, c, d, e, f, g,
X is equal to small a b, what set
small a,
set
yeah, it's a set, yeah.
A B C D E F G. Okay.
And capital A equals to small a, b, c, d, it's a set.
A B C D. Okay.
And capital B equals
Hmm.
to c, d, e, f.
Okay. Hmm.
Then verify that
Hmm.
A union B,
A union B
like do you
whole.
call that Parker? Yeah, that's C thing.
A union B complement.
Okay.
So they have not taught anything about this and they're just randomly asking. Huh?
Yeah, like this is an exercise. So just
Hmm.
said go through it, and everyone apparently knows in class. I don't know how. Not everyone, like
Hmm.
five, six of them, and
Okay.
so things learn.
Okay, fine. Okay, so you verify that this is equal to what? You have to find it, no?
A C.
A, C. Oh, set.
Yeah,
A set.
yeah. No,
This.
no, no. Like the complement, the same
Oh,
way
okay,
we
okay,
wrote.
okay. Verify that this is equal to this.
Yes, yes, yes.
This is De Morgan's laws only. Okay. So we'll understand what is the meaning of all this. So complement of a set. Complement of a set which is written as A power C like this, right? A complement. You can call it A complement, sometimes also written like this. Okay. So
Okay.
this means so this means another set which has all elements which are not in A,
Okay.
not
Which are
in.
not in
So basically, let's say we have a universal set A, and this is small set A. Universal set means all possible values of the elements, right? So for example,
Okay.
here my universal set is from A to G, right?
Yes, yes.
Nothing else is there, no? A to G, the numbers are
Yeah.
there, letters are there,
Yeah.
right? So universal
Yes.
set is A to G. Then A set was A B C D, right? A B
Mhm.
C D, right?
Oh, so then EFG.
E F G H are outside A, no? E
Yes.
F G H are not inside
Yes.
A, right? So
Yes.
A complement is just equal to E F G H. Anything that is not A
Okay.
complement is called anything that is not A, right? So,
Okay.
so EFGH is not A. Okay. So now
Okay.
in this question though, you have to do something else. So A complement intersection B complement. So B complement is what? Tell me. B complement is
B complement is which is AB,
AB,
AB, ABG, ABG.
ABG. That's it, right?
Yeah.
So B complement and A complement intersection is what?
Intersection means like all of them, like AB, EFG.
No, no. Intersection means and.
Oh, oh, that one. Okay.
Intersection means
And the
and.
common.
Common ones, right? So
Okay, so
intersection
it's
is
G.
just G, right? So A complement intersection B complement is just G, right? Only a single element, right?
Yes, yes.
Basically, this gives the answer as a third set with just one element called G, right?
G. Okay.
Now
Yeah.
this side, if you do A union B, what are you A union B? Or union means or, right? So it
Okay,
is
so A, B, C, D, E, F.
A B C D E F, correct? This is or, and now you take the whole complement. What is there that is not in this?
G. G.
That's it, right?
Oh, okay.
Okay, so
Understood.
A union B whole complement is G, and it is also same as A complement intersection B complement,
Okay.
right?
Understood.
So these are just laws that you need to be familiar with. So for example, A union B intersection C, okay, this will be equal to A intersection C union B intersection C. So for example, let's test it out, okay? Let's draw a figure. Let's say A is 1, 2, 3, B is 2, 3, 2, 4, 5, and C is 7. Okay. Okay.
Okay.
And C is 7 and 6, 6 and 7. Okay. So, okay, just make it 6. Okay. Nothing else.
Okay.
6. So this is A, this is B, this is C. Okay. So
Okay.
universal set is my A plus B, everything 1 to 6, right?
Every 1, 2, 3, 4. Yeah.
So let's do A union B. A union B is A 1, 2, 3,
A,
4, 5.
3, 4, 5. Yeah.
1, 2, 3, 4, 5. And
Yeah.
intersection with C is nothing,
C.
no?
Nothing. Yeah.
Null set, right?
Yes.
So now let's do A intersection C. A
A
intersection C is
intersection
what?
C is
Null
also
set.
nothing. Yeah.
Union B intersection C is nothing. Okay, this was a very
That.
easy example, so it became nothing. But if
Yeah.
all three were intersecting also, it would work out, is the point. So let's say like this, right? Okay. One,
Okay.
2, 3, 4, 5, 6, 7. Okay. This is
Okay.
A, B, C. So I have marked out all the elements that are in each of the regions. Okay. So
Yes. Fine.
A union B. Let's find out A union B.
B is
1, 2,
1,
3,
1, 3, 4, 5, 6. 1 to 6.
4, 5, 6. Correct. 1, 2, 3, 4, 5, 6. An intersection with C. C is 4, 5, 6, 7. No?
Yeah.
C is 4, 5, 6, 7. Intersection of
Four,
these two is what? 4,
4,
5,
5,
6.
6.
Right? Let's
Yeah.
do A intersection C. A intersection C is what? 5, 6.
6 and 5. Yeah, 5 and 6.
5 and 6. And B intersection
Yes.
C is what? 4 and 5.
4. 4 and 5.
4 and 5 union with 5 and 6 is what?
4, 5, 6. Okay.
Makes sense. So,
Yes.
so this is
Yes.
one De Morgan's law. Okay. This is one law which is always true. Similarly, you will have a similar looking law. You can go back and verify these things. You can read up on these things from Khan Academy or Brilliant anywhere nice on YouTube, or just
Okay.
check it out. Okay, it's very easy stuff.
Fine. I-
Uh,
I-
now, another law which looks exactly like this is this. So basically, union and intersection and complement are distributive like this.
Okay. Okay.
See the same pattern. This was A intersection
This
B
is,
whole union with
it
C.
was, yeah. Yeah.
You can put you are
Okay.
doing A union C and intersection with B union C. The
Yes.
earlier
Yes.
formula that I wrote was this. See, this will be A intersection C union with B intersection C. These are De
Yeah.
Morgan's laws. Okay, so that the other formula was the complement formula that becomes A complement intersection B complement. So complement union becomes intersection afterwards.
Okay. Okay.
So it this one will be A complement union B complement. Okay.
Okay. I get
Okay.
it.
So
Okay.
it's not very hard once you look at it a little bit. So just check out in the Fiji books. If you have online books and all available there,
I,
you will be able to see the properties list of properties. Okay. If you see the list of properties in set theory, they will have mentioned set theory somewhere, I'm sure.
yeah.
So
Yeah. Like sir just gave these
yeah.
like verbally, so I can
Okay.
check them out.
Okay, so just check it once. Wherever you find a good list of properties, just try to verify all of them yourself. Take some simple
Yes.
sets and see if it works
Oh,
out, right?
okay.
So
Okay.
complement, union intersection, sometimes you
Yes.
also get a difference of two sets. So what is A minus B? A minus B is set of all elements that are
In A.
in A but not in B. You understand?
Okay.
So you have
Yes.
something like this. This is some elements, right? So these
Yes.
four will be A minus B. They are in A but
Oh,
not in B,
not in B. Okay.
right? So
Okay.
A
Fine.
minus B is defined like this. This is called difference of two sets. Difference of two sets. So
Okay.
just go through these definitions. It's not hard. Okay. Okay.
Okay.
Let's. If there is any
Um,
other doubts, tell me.
and there is one more. It's on mod.
It's on what?
Uh, Modulus.
Okay.
It's like modulus of x square plus 3x plus 5
Hmm.
plus
Hmm.
x square plus 3x plus 5
Okay.
equals to 0. Solve for x.
Okay. Fine. So okay. Uh, this is looking like something like this. If you take x squared plus 3x plus 5 as t, right? This is the equation, no?
Yes, yes.
If t is greater than 0, I can write modulus as mod t will be
T.
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 So then
Yes.
the equation will become 2t is equal to 0,
Yeah.
right?
Yes.
So it
Yes.
will become t is equal to 0 is the equation then.
Yeah.
Does that
Yeah.
equation
Yeah.
have any solutions? X squared plus 3x plus 5 is equal to 0 will not have any solutions because
It doesn't because
discrim
5 and yeah,
no real
it's not.
solutions because discriminant is 9 minus
Is
20.
yes, it's less negative.
Or you can also say that it is x plus 3 by 2 whole square plus 9 by 4, 5 minus 9 by 4, so 11 by 4
Yeah.
is always greater than 0. It can never be 0, no?
Yes. 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 Okay.
This is called that splitting it and making it a perfect square, right?
Yeah.
correct? Now,
Yes.
so if t is greater than equal to 0, there is no solution to this equation, right?
Yes.
If t is less than 0, then the equation
Mm.
becomes 0 is equal to 0, no? Because t, and this becomes minus t.
Yeah, yeah, yeah. Yeah.
So then all values will satisfy, all values of x will satisfy,
Yes.
because the equation has become an identity, no?
Yeah, yeah.
Identically it will be 0, right? So,
Yes, yes.
but is t ever less than 0? X squared plus 3x plus 5 is never less than 0, no? Just now we saw.
Yeah, it cannot be this.
So no solutions to this equation ever. That is the
Oh,
answer. You
okay.
understand? For the case when the thing is always positive, no?
Mm-hmm. Yeah.
So the only equation is this, t is equal to 0, right?
Okay. Fine, I get it.
Right?
Understood.
And it will never
Yeah.
be 0 also. So no solutions are
Oh,
possible for this, right?
okay. Understood.
Okay. Next one.
That's it for Fiji. We learned limits today.
If you have any doubts in limits, you can ask me. You understood
Uh,
what is limits and all.
I did, but like partially, like the left hand limit, that part I didn't understand. There was like
Okay.
left hand limit and right hand
Yeah,
limit.
yeah. Suppose x is equal to 1, and this is some y is equal to x cube minus x or something, right?
Okay.
Okay. So x cube minus x plus 1. So basically left hand limits means you are approaching 1 from this side, so just below 1. So as you come from say 0 onward, 0 0.1, 0 0.2, 0 0.9, then you go to 0
Mm-hmm.
0.99, 0 0.999, right? You're getting
Mm-hmm.
closer and closer to 1, no?
Yes. Yes.
As you get closer and closer to 1, limit x tends to, you can write it as x tends to 1 minus of fx, which is x cube minus x plus 1, right? So
Yes.
that means you can also write it as limit h tends to 0 f of 1 minus h. See, if you put h tends to 0, this is slightly less than 1, right? The value
Yeah.
of
Yeah.
the x value is
Yes.
slightly less than 1, no?
Yes. Yes.
So this is the same thing. This is the left hand limit. So left hand limit can also be written as h tends to 0 f of a minus h. This is left hand limit of x tends to a minus f of x, right?
Okay.
So
Okay.
near a, you are going slightly less than a, right? So the
Yes.
way you calculate the limit is put the value of numbers nearby, close to this point, but slightly less. So 0.999 and all. If you put, you will get
Okay.
some tendency. You will get y tends to some value, right?
Okay.
Y will tend to some value because of this, right? So as
Yes.
soon as
Yes.
you get that, you will realize that you will say limit exists only if both sides the tendency is same. Right hand limit will be limit x tends to 1 plus f of x. That should also be the same as limit x tends to 1 minus f of x. Then you will say that limit exists.
Yeah.
So right hand limit is you start from 1.0001 or get closer to it from there, 1.00001, right? You're getting closer and closer to 1, but not exactly equal to 1, right?
Okay.
As close as
Understood.
possible without being equal, right? So there
Okay.
are actually infinite numbers, no, there we can get as close as you want, right?
Yes. Yes.
So both sides, if the value of the function approaches some same number L, if
Mhm.
this, as you get close to 1 from the upper side, from the right side, or from the left side, if the number that comes, the value of the function, if that
Yeah.
is same, then you say that limit exists and the limit is equal to that value.
Okay. Fine.
So uh, for example, you can have something like this, a function like this, which is y is equal to x square plus 1 for x is less than equal to 0, and x square plus 2 for x is greater than 0, right?
Yes.
This is x square plus 2, this is x square plus 1. So this overall function is defined in a piecewise manner. So the function definition has changed, right?
Mm-hmm.
So below x is less than 0, it was behaving like x squared plus 1. And after x
Yeah.
is greater than 0, it was behaving as x squared plus 2, right? So
Okay.
near 0, see, if you come from this side, function was which
Yes.
one? X squared plus 1, no?
Yes.
So the value was going to near 0. If you come very close to 0, 0.0001 minus, right?
Mm-hmm.
So the
Okay.
value has approached 1, no?
It yeah, yeah,
Because 0,
yeah.
very close to 1, x squared becomes close to 0 and plus 1, right?
Yeah.
The
Got it.
value is approaching 1 from this side. But if you come slightly above 0, plus 0.0000, you are on that curve, no?
Yes.
Square plus 2
Yes. Yes.
curve. So you will be approaching value 2, right? Correct.
Yeah. Yeah. Yeah.
You'll be approaching value 2 from that side and 1 from this side, right? This is the
Yeah.
case where you say that left hand limit is not equal to right hand limit. Left hand limit is 1, right hand limit is 2, right?
Mm-hmm. Naughty.
So left hand limit is not equal to right hand limit. So the function fx does not have a limit at x tends to 0. Does not have a limit at x tends to 0. Okay.
Okay.
Because both
Okay.
the tendencies are not the same. So what
Okay.
matters here is what is the tendency, like where are you limiting value, what is the limiting value? From this side it's 1, from that side it's 2. Okay.
Fine. Understood. Understood.
Okay. Next.
Okay. That's it
Trigonometry.
from Fitch.
Trigonometry.
Trigonometry from the booklet I have done from the exercise I have done like 1 to
Hmm.
6. After that I've done addition.
Because, this
In
is the
six,
ratios exercise, trigonometric
uh,
ratios exercise.
the first booklet that you had sent,
Yeah, yeah.
the one from which we were doing the examples. That
Okay, okay. And the other booklet also you have, no, trigonometric equations.
uh, I don't think so.
So then
I
you should,
don't have.
okay, so then you should remind me, dude. Remind me when if I have not sent it. So I'll send it today. Okay.
Okay. Okay.
Just send me a message if you feel like you don't have the. We did trigonometric equations in the last class, no? So you should have that booklet also. So I'll send it to
Okay.
you. Uh,
Fine.
okay. So
No,
tell me your
so
doubts from RD Sharma or this booklet or whichever one.
yes. Okay. Like in the booklet so far, like 1 to 6, I got it. Like I
So
didn't have.
so you should try the exercise 1 of the booklet because it will be slightly easier than the examples. You should actually just try the exercise 1, exercise 2, and so on. Okay.
Okay.
So
Fine.
you didn't have 1 to 6 any doubts, no?
No.
Okay. Next, then RD Sharma.
Yeah. There's a question.
Hmm.
If alpha and beta are
Hmm.
two solutions of the equation A
Hmm.
tan x
Of A tan x.
plus B sec x equals to C,
Hmm.
then find the values of sine alpha plus beta,
Hmm.
sine of alpha plus beta, and cos of alpha plus beta.
Okay. Okay. You have alpha and beta are two solutions of this equation. So you have two equations like this. A tan alpha will satisfy this. So B sec alpha is equal to C. You also have A tan beta plus B
B sec
sec
beta
beta
equals
is equal to C, right? Okay.
C.
So find the value of this, right? So first thing that I would do, because I need sine and all, right? So I will convert to sine cos here. That is an obvious thing to do. So I
Yes.
will make it A sine
Sine
alpha by cos alpha plus B by cos alpha, right? So
yes.
so A sine alpha plus B by cos alpha, right,
Alpha equals to C.
is equal to
Yes.
C. So therefore this becomes A sine alpha minus C cos alpha is equal to minus B,
Yes.
right? And the other
Yes.
equation will become similarly A sine beta minus C cos beta is equal to minus B.
Yes. Yeah.
Correct. So
Yes.
I have alpha here and sine beta here, right? So squaring and adding will work, yeah? Yeah, I think it will work.
I
Let's see.
agreed.
Squaring and adding, let's see. squaring this and squaring this and adding, right? So it will be a square sine square alpha plus c square cos square alpha plus a
Yeah.
square sine square beta plus c square cos square beta, right?
Goes
Minus 2ac sine alpha cos alpha minus 2ac sine beta cos
cos
beta is equal to 2b square.
square. Yeah.
So you're getting
This
sine square alpha and cos square
um
beta, right?
square.
Okay, so squaring and adding doesn't seem to directly work, but maybe we'll get a hint something. C square minus c square sine square alpha. Okay, so this is c square. Okay, 2ac common sine alpha cos alpha sine beta cos beta. Okay, okay, maybe this is not the way to do it then. We have to find the value of sine alpha plus beta. Basically, we have to find sine alpha cos beta plus
Plus
cos
cos.
plus sine beta.
Yes.
Okay, so we can do a sine x plus b is equal to c cos x. This is the equation. So a square sine square x plus b square plus 2ab sine x is equal to c square cos square x,
Yeah.
c square minus c square sine square x, right?
Yeah. Yeah.
So you get a square plus c square sine square
Science.
x plus 2ab sine x is equal to plus b square minus c square is equal to 0.
0. Yeah.
This is the
Yes.
equation that we get in sine x, right?
Yes.
Right. So,
Yeah.
okay, great. So one of the roots is sine alpha, one of the roots is sine beta.
Oh, the product and some.
So two of the roots are given, no? Alpha and beta are two roots of this, right?
Yeah.
So when you do sine alpha, it should fit. When you do sine beta, it should fit. So basically, sine alpha and sine beta are the two roots of this, right?
Yes.
This quadratic. So I know
Yeah.
product of the roots sine alpha sine beta is
Is
equal
equal
to
B square minus C square.
minus b square minus c square by a square plus c square, b square minus c square by a square plus c square. And I know sum of the roots sine alpha plus sine beta is equal to minus 2ab by a square plus b square, right?
Yes.
Minus 2ab by a square plus b square. So is it going to be useful for us to find sine alpha and all? Sine alpha and sine beta, if I find, then my job is done. No? I can just put the values here, right? You understand? Like it's not necessary to do these things. You can just find the roots, no, here.
And then can substitute.
Then substitute. So sine alpha or comma beta will be minus 2ab plus minus 4a square b square minus 4 b square minus c square into a square plus c square by
Yes.
2 into a square plus c square, right?
Yeah.
So
Yeah.
this becomes this root under root sign. If you want to think about it, becomes root over 4a square b square will cancel this one. So
Yeah.
let's just write these terms. So b square c square minus 4b square c square minus 4b square c square. Then you get a minus c square a square, so it becomes a plus 4c square a square.
Yeah.
And you get a minus c power 4, so plus 4c power 4, right?
Yes.
Correct.
Yes.
And the other term cancels, right? So
Yes.
4c square can be taken common here, so 2c comes outside. So this becomes 4c square is common, so c square plus a square minus b square, right? Correct.
Yes.
C square plus a
Yes.
square minus b square, and 2c has come out, and this side is minus 2ab plus minus, right? But this is annoying. Like the problem is that it's annoying to do. I am hoping for finding a simpler solution. Wait, like this can be done. You realize that it can be done, but it's annoying to do. This is the equation, no?
Yes.
Alpha, beta are the roots. We have to find sine of alpha plus beta. So what we have seen so far is make a quadratic in sine x and solve for sine alpha and sine beta, right? Once you
Yeah.
know sine alpha and sine beta, you can
Yes.
actually find this, right?
Cos, yeah.
There is no issue. See, cos alpha
Yes.
plus beta is slightly easier because cos alpha, cos beta and sine alpha, sine beta was coming, no?
Yes.
Sine alpha,
Yes.
sine beta comes as product of the roots and all,
Product of roots.
right?
Yes.
So this is
Yes.
slightly easier than this, but still, like it is still annoying. So let's
So
hope
should
for
I
some.
write?
I'm hoping for something smarter. So wait, two roots. So b square sec square x is equal to c square plus a square tan square x minus 2ac tan x, right? So this is b square plus b square tan square x is equal to c square plus a square tan square x minus 2ac tan x, right?
Yes. Yes.
So we get equation b square minus a square tan square x plus 2ac tan x plus b square minus c square is equal to 0, right?
Yes.
This equation has roots tan alpha and beta, so the roots are tan alpha and tan beta, right? Oh,
Yes.
now it will be better because tan alpha plus tan beta, you know now,
Yeah.
is
We
equal
do.
to
Yeah.
what?
Minus two
Minus
is
2ac by b square minus a
5.
square. So it is 2ac by a square minus b square.
Yeah.
And tan alpha into tan beta also, you know now, which is equal
Yes.
to b square minus c square by b square minus a square, right?
Yeah. We can find tan alpha plus beta.
Correct. So find tan alpha plus beta directly. So that is numerator by 1 minus. So numerator is 2ac by a square minus b square by denominator is 1 minus, right?
Yeah. 1 minus b square minus. Yes.
This thing.
Yes.
So it becomes b square minus a square minus b square plus c square. So b square
Yes.
cancels. So c square minus a square, right? So
Yes. Yes.
2ac by a square minus b square into c square minus a square and into b square minus a square. This becomes cancel minus 1. This cancels and becomes 2ac by a square minus c square, right?
Yes.
This is my tan a alpha plus beta. So this must be the perpendicular and this must be the base, right? Correct. So
Yes. Yes.
hypotenuse will be root over a square minus c square whole square plus 4a square c square.
Mm-hmm.
This will become a square plus c square.
Yeah. Yeah.
So sine alpha plus beta will be 2ac by a square plus c square. Cos alpha plus beta will be a square minus c square by a square plus c square. So this is the best way to do it. So if you make a trigonometric equation in sine x, it will be really annoying. The
So
equation is not nice.
but square it. Okay.
Equation was
Understood.
not nice because sine square x and all is not coming nice values, right? So it is difficult to find sine alpha plus beta from there, right? But here, if you get an equation in tan x, it is really nice, right? So what did I
Mm,
do? I used the fact that sec square x is 1 plus tan square x.
yes.
And I
Okay.
got an equation in tan x, and tan x equation, I will have roots of tan alpha, tan beta, because alpha and beta are roots of this equation, right?
Yes. Yes. Understood.
So after that, it's
Oh,
over, right?
yes. Understood. Understood.
Okay. Next.
Okay. Next question. Yeah. If angle theta
Hmm.
is divided into two parts
Hmm.
such that the tangents of one part
Hmm.
is lambda times the tangent of the other,
Hmm.
and the difference is phi.
Their difference is 5.
Phi. Yeah.
Okay.
Then show that sine theta
Hmm.
is equal to lambda plus 1 by lambda minus 1 into sine phi.
Into sine phi like this.
Yes. Yes.
Okay. Okay. So, okay, instead of doing proving this, I will prove this sine theta by sine phi is equal to lambda plus 1 by lambda minus 1. Okay,
Yes.
correct.
Okay.
So
Yes.
so instead of proving this, I can also prove this, no, componendo and dividendo.
Oh, okay. Yeah. Fine.
Since
Yes. We can.
this is equivalent statement, so add and subtract. So add it,
Yeah.
2 lambda
Two.
by 2, right? So lambda.
Yeah.
So if we can prove this, then also it's equivalent to all of this, right?
Yes.
So what is lambda? Lambda is tan alpha by tan beta, right? Right,
Yes. Yes.
right. And let's do this thing. Let's do this calculation. So sine theta plus sine phi by sine theta minus sine phi is
Yeah.
equal to,
Of
on top it is 2 sine theta plus phi by 2 cos theta minus
course.
phi by 2
Minus.
by 2 sine theta minus phi by 2 cos theta plus phi by 2, right?
Yeah. Yeah.
Let's try to figure out what is this theta plus phi by 2 and all, right? Theta plus
Mm.
phi is what for us? See,
Theta. Okay.
2
Two
alpha. So theta plus phi by 2 is alpha, becomes 2 sine alpha. Theta minus phi is what? Theta minus phi, see,
theta minus phi is
2 beta.
two.
So cos beta by, what is this? 2
Uh,
sine
theta
beta and cos
cos.
alpha. So isn't it tan alpha by tan beta?
One second. One second. Which formula are we using this?
No formula. See, sine alpha by cos alpha.
Achha, okay. Fine, I get it.
So basically what we said is, instead of trying to prove this, I will try to prove this. Instead of trying to prove this, I will do componendo and dividendo and try to prove this. Okay. So my job is
Okay.
to try to prove this. So I'll start with this.
Mm.
Started with this here, did this till here, right? Then I
Mm.
noticed that, wait, theta is alpha plus beta and phi is alpha minus beta. So this immediately becomes tan alpha by tan beta, no?
Yes, got it.
And that is lambda. And now I have basically proved that it is equal to lambda. If I have proved this, I can do reverse componendo and dividendo again. It will become this, and then you can prove it, right?
Okay, I understood.
You
Fine.
understand? So whenever you get
Yes.
some ratios and all, no, componendo and dividendo is something you should think of. Whenever there are
Okay, I did.
something is lambda times something, there's some, and see here, the hint that I got, that why componendo and dividendo is because it looks like this. See, if it is a plus 1 by a minus 1, I will obviously always think of componendo and dividendo. If I have to say this is equal to something, c by d, instead of proving this, I will always prove c plus d by c minus d is equal to a by 1. No, that is much easier.
Okay, yeah.
I will do componendo and dividendo and prove this, try to prove this.
Okay,
So as
okay,
soon as you get a thing like this, lambda plus 1 by lambda minus 1. So sum of two things divided by difference of two things, think of componendo and dividend.
okay, fine.
Okay, next.
Okay. Next one is yeah. If sine alpha plus sine beta equals to A
Mhm.
and cos alpha plus cos beta equals to B,
Mhm.
show that sine of alpha plus beta is 2ab by a square plus b square.
This, so now you know, no, hundreds of times you know.
Yeah, adding, squaring
Squaring
and
and
adding.
adding, there's nothing to
Yeah,
do, only square and add, it's over.
yeah,
So it will become
yes. I understood.
1 plus 1, so 2 plus 2 cos alpha cos beta plus sine alpha sine beta.
Sine beta.
So this will directly give you not the thing
Yes.
that you want. It is giving you cos of alpha minus beta.
Alpha minus beta.
So instead of that, do squaring and subtracting. Maybe no, squaring and adding you have to do. So cos of alpha minus beta you have gotten. Okay.
Yes.
So then we need this one. So maybe you need a tan thing, right? Uh,
Tan.
cos of alpha minus beta we have gotten, which is equal to cos of alpha minus beta is equal to a square plus b square minus 2 by 2, right? Okay. So sine of alpha plus beta is sine alpha cos beta. Sine alpha cos. So just multiply it. No? Multiply it. See what happens. Sine alpha cos beta plus
Sine
sine alpha cos alpha
cos alpha plus
plus
sine
sine beta cos alpha
cos alpha plus
plus
sine
sine
beta
beta cos beta.
cos beta.
Right? So
Yeah.
you are getting
Sine,
one term which is sine
yeah.
of alpha plus beta,
Plus beta, yes.
and this term is half.
Cos.
Oh wait, this is cos of something. No.
Cos of alpha.
No. This is not that, right? You
No,
have
no,
to have,
no.
so
Same
this will,
angle.
so this is half sine 2 alpha plus half sine 2 beta,
2
right?
beta. Yeah.
AB is equal to this, right?
Yes.
So AB is equal to AB minus half sine 2 alpha plus sine 2 beta is equal to sine of alpha plus beta, right?
Yes.
So this one, can we write it
Simple.
as 2 sine alpha plus
Sine alpha
beta
plus beta.
cos alpha minus
Cos
beta
minus beta, yes.
minus half into this, right?
Yeah,
So
yeah.
this becomes this AB minus
A
this AB minus this thing
is sine alpha plus, yeah,
is
equals
equal
to
to
sine.
sine alpha plus beta, right? So now
Yes.
take this on the right hand side. So you get sine alpha plus beta common, and
Yeah.
1 plus cos alpha minus beta is equal
Yes.
to AB, right? So
Yes.
sine alpha plus beta is AB by 1 plus cos alpha minus beta.
And cos alpha minus beta we had got there.
We had gotten already. So you get it as a square plus b square minus 2 by 2 plus 1. So 2 plus this becomes a square plus b square,
It's
2
is
cancels. So it
yes,
becomes
yes.
2ab by,
Yes.
right? So,
Yes.
okay, so it was not so straightforward. The straightforward thing was this.
Yes.
After that,
Yes.
I noticed that really what do you need? Sine alpha cos beta plus cos alpha sine beta. So how can
Yes.
I get that? Maybe multiplication directly, no?
Yes.
So I did the multiplication. Once I did the multiplication, I got one term that I wanted and two terms that were not really necessary. So
Mhm.
I brought it to this side, used a formula, got it.
Yeah.
Again, the same term that I wanted appeared. So I have to bring it back here and take common and stuff, right?
Okay.
And
Understood.
thankfully, I ended up with cos alpha minus beta, which was already obtained.
It's already there. Okay.
Right?
Fine.
Okay, next.
Next is if alpha and beta are two different values of x lying between 0 and 2 pi.
X belonging to 0 and 2 pi.
And 2 pi, which satisfy the equation 6 cos x plus 8 sin x equals to 9. Find sine of alpha plus beta.
See, this you should have done because we have done that theory, no, root a square plus b square theory.
The maximum value of
That
this.
type of thing only. No, this is an. I think it is similar thing. So let's see. But even if it is not, it's the same question again. No, so two different values of x satisfying and all. Sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. So let's think of what we can do. Okay, so let's see, 6 cos alpha plus 8 sine alpha is equal to 9. You have 6 cos beta plus 8 sine beta is equal to 9.
Yes.
So, okay. So, one second, let me just think a little bit. Let's use that maximum minimum theory and let's see if that works or not. So, multiply by root of 6 square plus 8 square and divide by the same, right?
Yes.
Square cos x plus 6 8 by root over
8
plus 8 square sin x
yes.
is equal to 9, right? So
Yes.
this becomes 6 by 10. 6 by
6
10
by
cos x plus 8 by 10 sin x is equal
yeah.
to 9 by 10,
9
right?
by 10. Yeah. Yeah.
So if I say this is also less than 1, this is also less than 1, let's make it a sine function. So let's call this sine p and let's call it cos p. Okay. I
Okay.
don't know the value of p, right?
Yeah.
So this is sine p cos x and this is cos p sin x. It
Yeah.
becomes sine of
9
p plus
P plus
x
X.
is equal to 9
Yeah.
by 10 is my equation, right?
Yes.
Okay.
Yes.
This is my equation. So
Yes.
now what is the same equation has become this, no? So alpha and beta are still roots of it, right? Are roots of this equation also, no?
Yes. Yes.
Makes sense. Sine
Yes.
of
Yes.
p plus x is equal to 9 by 10, right? Correct.
Yeah. Yes.
So what we know is that sine of p plus alpha is equal to 9 by 10 and sine of
P
p
plus beta
plus
is
beta is equal to 9 by 10, right?
yeah. Yes.
Correct. So what we have then is, if you do, and we know sine p is equal to 6 by 10 and cos p is equal to 8 by 10, that also we know, right?
Yeah. Yeah. Yeah.
Now think about it. If uh, same value 9 by 10, two values of the angles, right? Two angles are equal to that, right? P plus alpha and p plus beta, right?
Yeah.
And it is positive, no? Positive. So sine is positive in its first and second quadrant.
Yeah.
So the angles that satisfy this should have a relationship, no? They should be like this: theta and pi minus theta.
Yeah. Yeah. Because first one, yes.
This,
Okay.
see, if you had something like this, suppose sine A is equal to 9 by 10, you would have two angles that satisfy, no? One angle would be some
Yeah.
0 to 90, another angle would
Yeah.
be 180 minus that angle,
Yes. Yes.
right? So I'm
Understood.
saying P plus X should be theta, then P plus alpha is theta, then P plus beta is pi minus theta,
Yeah. Yeah. Yeah.
right?
Okay.
So
Okay.
you understand what I'm saying?
Yes. Yes. I
So
understood.
the sum of the two, P plus alpha plus P plus beta, is equal to pi, no?
Mm-hmm.
Right?
Yes.
So alpha plus
Yes.
beta is equal to pi minus 2p,
Yeah.
correct? So sine
Yes.
of alpha plus beta is equal to sine of pi minus 2p, so sine of 2p,
Uh, yeah. Yeah. Yeah.
right?
Okay. Okay.
It is equal to
Yeah.
2 sine p cos p.
Mm-hmm.
2 times sine p is 6 by 10, cos p is 9 by 10, 8 by 10,
Oh.
right? So this
Yes.
becomes 2 into 6 in 48, 96 by 100. So it is 19 by 20. Check the answer once. No,
Nine.
not 19, 19 by 25.
Nine.
24 by 25. What am I
Yeah.
saying?
Yeah. Yes. Yes.
96 by 100, right? 24 by 20.
Yes. Yeah. Yeah. It's that only.
So again, we'll revise it because this is like a tricky solution. So
Yeah.
6 cos x plus 8 sin x is equal to 9, right?
Yes.
This was the question, and there were two roots in 0 to 2 pi. So
Yeah.
instead of doing some long calculations and all, I have to find out sine alpha plus beta, right? Two roots are alpha and beta, right? So what I did was I made it 6 by 10 sine of x plus some unknown angle, let's say p, is equal to 9 by 10, right?
Yeah.
6 by 10 I did not make, I made it this, right?
Hmm.
because
Yes.
this can be written 6 by 10, 8 by 10, 9 by 10, right? And 6 by 10
Yes.
became your sine p and 8 by 10 became your cos p, right?
Yes.
So I got the same equation looks like this now, where sine p is equal to 6 by 10 and cos p is equal to 8 by 10, right?
Yeah. Yes.
Okay, awesome. So now we have two roots of this equation. Two roots are alpha and beta. So roots
Beta.
means you can substitute for x. Sine p plus
Yes.
alpha is equal to 9 by 10, and also sine p plus beta is equal to 9 by 10, right?
Yeah.
Now, if the roots are only in the first quadrant, 0 to 2 pi, then sine will have positive values only in first quadrant. So
Yeah.
this angle, if we call this angle as theta, then this angle must be pi minus theta.
Theta, understood.
So this
Yes.
is equal to p plus alpha. This is equal to p plus beta, right? So pi is
Yes.
equal to p plus alpha, p plus beta plus p plus
Plus
alpha.
beta.
So
Yeah.
alpha plus beta is equal to pi minus 2p. So
Mm.
sine alpha plus beta is equal to sine 2p, right?
Okay. So sine p cos p, understood.
Right. So this is much faster and much nicer than anything else you could have done, right?
Yes.
It would be annoying to actually make an equation and solve it. You could do it in a regular way by doing 6 cos x is equal to 9 minus 8 sin x, right? Square
Yes.
it.
Okay.
Square it, and this cos square convert to sine square, right?
30.
36 minus 36 sine square is equal to 81 plus 64 sine square x, right?
Minus,
Minus
yeah.
2 into
Uh,
8, 16
8
into 9, so 144 sine x,
sine
right?
x.
So you get 100 sine square x minus 144 sine x plus
Yeah.
55, no, 45 plus 45 is equal to 0, right?
Yes.
This is
Yes.
my equation which has roots alpha and beta. So sine alpha, sine beta are the roots.
Are the roots, yes.
Sine alpha and sine beta, you can say sine alpha plus sine beta is equal to 144 by 100, or sine alpha sine beta is, but those things are not helping you directly, right?
Yes. Yes.
So it is annoying. So you have to find actually sine alpha and sine beta, and then you can put
And
the values in this. No, after that,
yeah, then fine.
find
It'll
cos
be
alpha, cos beta. It will be long and horrible,
very long, yeah.
right? So,
Yes. Yes.
but it is solvable also like that. It's not like it's not solvable. It's just going to be long. So,
Yes.
better use this idea. This idea is nice. This a cos x. Whenever you see a cos x plus b sin x, no, maybe
Mhm.
think of this thing: root of a square plus b square into cos of x plus p, or sine of x plus p, or something, right?
Okay. Fine.
You understand that maxima minima
Yes.
idea? That is going to be
Yes.
useful. Okay.
Okay. Understood.
Next.
Next one is, yeah. If cos A plus sine B, capital A, yeah, yeah,
Mm-hmm.
cos sine B equals to M,
Mm-hmm.
small m. Sine A plus cos B equals to N. Then prove that
Mm-hmm.
2 sine of A plus B
Mm-hmm.
is equal to M square plus N square minus 2.
Okay. Okay. Again, as soon as I saw this, I am thinking of
Um,
componendo and dividend. Uh,
Here,
M by N and all. I'm thinking. Okay, maybe not, but let's see. Uh, uh, Cos A plus sine B, and okay, sine A plus B you have to prove. Okay. So okay. So okay, squaring and adding gives you many things. Okay, it's over. Squaring and adding. See? It's over, dude.
then yeah, yes, yes. Okay, okay. It was very easy.
Yeah. So see, I have only 2, 3, 4 things that I know, and I keep checking which one will work, right? Squaring and adding, ratios, componendo and dividendo, maxima, minima of a cos x plus b sin x. Some
Okay.
few tricks are there, okay? So the more
Okay.
questions you see and the more applications you see, then you will also be able to apply them whenever, right?
Okay.
It's about getting familiarity with these tricks, right? So make sure that when you are learning these things, you're not ignoring it and moving on without reflecting on it a little bit. You understand?
Yeah, yeah. I do them again.
You should do them again, or keep a small note somewhere where you make a tiny mark on, okay, this was the idea here, right? This question, this was the idea. Somewhere you should have a reference point so that when you have done the chapter and moved on, 2 months later you can come back and revisit and see all these key tricks, right?
Yes.
You
Yes.
understand? Something like that has to be created as during the process of learning. Okay,
Yes.
next.
Yes. Yeah. If tan A plus tan B equals to A,
Hmm.
cot A plus cot B, B equals to B, small b, then prove that cot of A plus B equals to 1 minus A minus 1 minus B. No, wait, 1 by A, sorry. 1 by A minus 1 by B.
Like this.
Yes.
Okay.
Now then if
So instead of finding cot A plus B, I can find tan A plus B.
and plus B.
So cot A plus B, I have to prove that it is equal to B minus A by AB. So I have to prove that this is equal to AB by
AB
B minus A.
minus
Right. Okay.
A. Again, please.
Uh, I can just, this is brute force also I can do. Like, no need to do anything. Just, let's just find out AB by B minus A. No, it's not even hard. Multiply AB, right? So,
1
okay, tan A cot B, tan
tan
A
A
cot B plus tan
plus
B cot A plus tan A cot A plus tan B cot
plus
B, right? So
plus
plus
2
2 by B minus A,
is cot
cot
A
A
minus
minus tan A plus cot B minus
minus
tan B, right? Convert
okay,
everything to tan, 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 everything in tan, right? So I'll write here. So it is tan A by tan B plus tan
plus
B by
tan
tan A
plus
minus 2 by tan
minus
A, 1 by tan A minus tan A plus 1 by tan B minus tan B,
yeah, it was
right?
plus 2 there on the new
Plus
in the
2,
new.
yeah, plus 2, yeah. So on top becomes tan square plus 2 tan A tan B.
Yeah, yeah.
So it on top becomes tan A plus tan B whole square
Mm-hmm.
by 2 tan A tan B,
Yes,
right? And
yes.
denominator becomes, let's take tan A tan B in the denominator. So it becomes tan B
Tan
minus tan square A
and
plus
tan B,
tan A minus tan,
tan
oh wait,
square
tan B, it becomes tan B
minus
minus
tan
tan A
square
tan
A,
B,
tan square A tan B,
tan square A tan B plus tan
tan
A
A,
minus tan square B tan A,
yeah,
right? Divided by tan
yes,
A tan B, right?
yes,
So 2 is not there, just tan A tan B is there. So this cancels out, no? The denominators cancel out, right?
yeah, yeah,
And here I will say tan A plus tan B common and minus tan A tan B. It's obvious. 1 tan A plus tan B gets cancelled.
yeah, yeah.
Tan A plus tan B in the denominator, if you take common, it becomes 1 minus tan A tan B.
Tan B, yes.
And one of them factors gets cancelled there. So it becomes
Tan A, yeah,
tan A plus B.
one,
No?
yeah, good.
I have
Okay.
proved that AB by B minus A is tan A plus B.
Then it's
Then it's
okay.
done, right? Okay.
Yes.
So all of these questions where I feel like these are all questions from the same exercise.
Yes, they are. Yeah.
So then don't do hundreds of them.
Oh,
Like,
like they were of the same type, so one I was not getting, like,
okay,
so I was
yeah,
stuck.
but don't do many things of the same type. It's just once you get the hang of it, just move on to other things, other types. Okay. Anyway, the class
Uh,
recording I am recording it, so I can share the recording with you later. Okay. Next.
One more is tan squared. Prove that
Hmm.
tan squared 2x
Hmm.
minus tan square x
Hmm.
divided by whole
Hmm.
divided by
Hmm.
1 minus tan square 2x tan square x
Hmm.
equals to tan 3x tan x.
Tan 3x tan x. Okay. 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 So this is tan 2x minus tan x into tan
Tan
2x
plus tan x.
plus tan x. This is very easy. This is 1 plus tan 2x tan x.
Okay.
It's over, no?
This, yes, yes. Mm-hmm.
You understand? You split this as x plus y, x minus y. Take the
Yes,
opposite factor here so that it becomes tan a minus b, tan a plus b, and
got
this
it.
becomes tan a minus b,
Mm-hmm. Understood. I
right?
didn't think that it was yeah.
Yeah.
Oh,
Tan. So this is just checking formulas and all. Okay.
okay.
Hmm.
Okay. One more is tan. Prove that
Hmm.
tan pi by 12
Hmm.
plus tan pi by 6
Hmm.
plus tan pi by 12 tan pi by 6 is equal to 1.
This
Yeah, I have to prove that.
this thing, right?
Yes, yes.
Okay. Is equal to 1. Okay. So okay. So this is not very hard again. Let's uh, think of what is this tan pi by 6 plus pi by 12. What is pi by 6 plus pi by 12?
2, 3 pi by 12, 3 pi by 4. Yeah,
And notice that 1 is there. It can be written as tan
1
pi by
plus
4.
tan pi by 4, yes.
So
But
now
we
you have
need to
understood.
express this.
So you can write this as pi by 12 plus pi by 6, no?
But like the
1.
plus, yeah,
1.
but
Uh-huh.
what to do with the plus tan pi by 12 tan pi by 6?
So
Plus,
I'm sure it will work out nicely. Let's see. Uh, uh, we have to prove that this is 1, no?
yes,
So,
you have to prove
so this is equal to 1, so I know for sure, right?
yes, yes.
So I have tan. Let's expand this one.
Okay. By 1 minus tan pi by 12. Yes.
Is equal to 1. Now you have seen how it is proved.
No, okay. Yeah. But okay, so fine, fine.
You start from
Okay.
here. Tan pi by 4 is 1, no?
Yes. Okay, okay.
So start from
Fine.
here and get it like that, right?
Okay, the reverse way. Fine.
The reverse, like multiply this side and add it. Then it becomes 1.
Okay, understood.
So the reason I was able to solve it was because I saw that pi by 12 plus pi by 6 is pi by 4 and tan pi by
Pi
4
by
is 1.
which is 1. Okay.
That is why. That is the idea. That is what gave me the hint ki how to solve it. Okay.
Okay.
So
Okay.
so whenever you are stuck with a question, you should worry about, okay, why is this particular angle there, right?
Yeah.
Why did they give pi by 12 and pi by 6? There must be some reason, no? And if it
Yes.
is working
Yes.
out so nicely, then let me just check the addition, subtraction. Let me just think in my head what is happening, right?
Okay. Yes.
Don't, if you are stuck somewhere, you have to explore possible options. Like you have to explore, like, why did they give this particular thing? Why did they give 2x and x like this and 3x and x, right?
Okay. Okay.
You understand?
Fine.
3x is
Yes.
2x plus x, and 2x is 2x, x is this, right?
Towards minus x. Yeah.
So
Okay.
be on the lookout for such things. Things are hidden in plain sight, right? You
Mm-hmm.
understand? Like here, you did not see this fact that it is pi by 4. That's why you could not solve it.
Yeah, I didn't see that.
Because
I
you
was
did not check
looking at
the
the
angles.
LHC.
You did not check the angles. Okay. So
Okay.
be aware that such cheap tricks can happen. Like pi by 12 plus pi by 6 is pi by 4. If somebody
Oh,
had given you 15 and 30, you would have seen, no.
yes, yes.
That's why they didn't
Yes.
give 15 and 30. You
Yeah.
understand?
Yes, I get it.
They gave it like this so that you could not notice that it is as 15 degree and 30 degree. And then
Okay.
45 degree you would have seen.
Yes, yes.
Okay.
Okay, fine.
Next.
Next one is yeah. If tan of a plus b is equal to x
Hmm.
and tan of a minus b equals to y,
Okay.
then find the values of tan 2a. Find the value of tan 2a and tan 2.
Find the value of tan. Okay. Okay. Now tell me, after the last bit of stuff that I was saying, you notice things and all. What is the one thing that you notice immediately now? Pay attention and think of what can you notice now. What do you need? You need this, and
And 2b.
so what should you think of? Think of the angle.
Uh, a plus b. Okay. Tan of a
A
minus
plus B plus A
b.
minus B is what?
Okay. Okay. Yeah.
You understand?
Yes. Yes. Yes.
And A plus B minus A minus B is what?
It's 2b. Yeah.
So that's over. Question is over, no?
Express it in the form of okay. I understood how to do it.
It's just x plus y by
Tan
1
a.
minus xy,
Yes. Yes. I understood.
right? So
Yes.
again, the reason you're stuck is because you're not thinking with your eyes open about what is the target, and what is given, right? The target is tan 2a. So can I think of why is this tan a plus b given? Why not tan a? If tan a was given, then I would have done different thing, right? Formulas.
Yeah. Yeah.
If a plus b is given, I thought ki, oh wait, 2a is a plus b plus a minus b. You understand?
Oh. Yeah. Yeah.
These are just things
Understood.
that have to be seen once and you'll never forget them, right? Like this
Mm-hmm.
idea you should not forget now after this.
Yes. I will.
Okay, next.
Next is prove that
Hmm.
cos square a plus cos square b
Hmm.
minus 2
Hmm.
cos a cos b
Hmm.
into cos of a plus b.
Multiplied by cos
Yeah,
of
yeah.
a plus b is
Is
equal to
equal to sin square a plus b.
sine square a plus b, like this.
A plus b. Yes. Yes.
Okay. Okay. Uh, okay. So now I'm thinking of what to do and all. So
Mm-hmm.
sine square a plus b. Okay. Prove that. Okay.
Yeah.
Hmm. Hmm. Cos square a plus cos square b minus 2 cos a cos b. Okay. 2 cos a cos b. 2 cos a cos b. I know a way to write it, I think. Yeah. 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 I know. Okay.
Oh, yeah, yeah.
I
No.
know a way to write 2 cos a cos b, right? It is cos of
Yes.
a plus b plus
Plus
cos
cos
of
of
a
a minus
minus
b.
b, right?
Yes. Yes.
And
Yes.
multiplied by cos of a plus b, right?
Plus. Yeah.
So this is like minus sign here, and there is a cos square a plus cos
Plus.
square b, right?
Yeah. Yeah.
So this becomes minus cos square a plus b minus cos of a plus b into cos of a minus b.
So a minus b. Yeah.
And this is an identity that we have discussed.
Yeah, cos square A plus cos square.
No, this identity.
No, the cos square A minus cos.
No, it is sine square B. That is the tricky bit.
Oh my god, I keep forgetting. Yeah.
You keep forgetting it, no? But
Yes.
try to remember it. Just write it down somewhere. Sine A plus B into sine A minus B is sine square A minus sine square B. Cos A plus B into cos A minus B is cos square A minus sine square B. Right? So this is the thing now, right? So now it is coming very nicely. See, it's so wonderfully arranged. This cancels this, and this
Yes.
becomes 1 minus cos square A plus B.
Yeah. Sine square A plus B.
Beautifully done.
Yeah.
Understand? So nicely it came, right?
Yes. Yes.
The only thing to notice is where should I start? Like how should I start simplifying it? So when I thought of this, making it like this, I didn't know that it will work out so nicely. But I just felt that because there is a cos A plus B there, and here also I'll get a cos A plus B and A minus B, things might happen, right?
Yes.
That is why I split it like this. Once I saw this splitting, after that, so it became obvious. A plus B into A minus B will become this identity. If you don't know this identity, then you have to do some calculations and all. Don't try to expand it and calculate it. It will still come, but it will come in many more steps, right?
Okay.
You understand? If you
Yes. Got
expand
it.
cos A, cos B minus sin A, sin B, then it will come, but it will be slightly longer and annoying.
Okay.
I expanded this instead, and then it becomes nice, beautifully done in 4-5 steps, right?
Understood. Understood.
Okay, next one.
Okay. Next one. Yeah. Prove that sine square n plus 1a.
N plus 1a.
1a, yeah. Minus sine square na is equal to sine of 2n plus 1a sine a.
Okay.
Yeah.
Okay. So, this is okay. I will not say anything. You tell me what to do. Just think of the last question and what we used here. Think of the last question and what identity I asked you to remember.
The sine square
Uh,
a minus 1 sine, no, this is not working.
what is the identity that you had forgotten in last question?
The cos a plus b into cos a minus b is cos square a minus sine square b, and sine of a plus b, okay, is sine square a minus sine square b. So it's sine of a plus b into sine of a minus b.
Okay, so what is it now then?
1 minute. So it's sine, 1 second. So sine, we can write this as sine of n plus 1 plus 1. So sine of 2n plus 1. Oh, it's direct. Like
You
that
understand?
identity.
Yeah.
Yes.
So, like, these are nice and useful identities. Please remember them.
Yes.
One step
It
it
was
came. No?
Yes.
Nothing is needed. Directly it is
Oh.
coming.
Yes. Fine. Understood.
Okay. Next one.
Next. Yeah. Prove that sin x by cos 3x plus sin 3x by cos 9x plus sin 9x by cos 27x.
Okay. So on.
Equals half of tan 27x minus tan x.
The whole half or just
The whole half. Yeah. This is
okay. 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 So first of all, I will not try to prove this. This half is annoying me, so I'll try to prove this.
Try to prove? Okay.
This. Okay. I'll try to prove this, and two sin x by cos 3x. I need some tans to come. No, this can be this only if some tan comes. Okay. So let me just, like, this is just a hunch. My hunch is this: tan 3x minus tan x, tan 9x minus tan 3x, tan 27x minus tan 9x. This is my feeling inside, that
Yes.
if this gets added, it cancels out, this
And
cancels,
can,
this
yeah,
cancels,
then,
and it becomes this, right? So
yes.
I am going to now check, can this thing be tan 3x minus tan x? Okay. Tan 3x minus tan x. What is the value? Sin 3x by cos 3x minus
Yes.
sin x by cos x, right?
Yes.
This is
Yes.
sin cos 3x cos x, sin 3x cos x
Mm.
minus sin x cos 3x, right?
Yes.
So this is sine of 3x minus x on top divided by
Yeah.
cos
Cos
3x
3x.
cos x. So on top it becomes
Sin
2 sine x cos x,
cos x. Yeah.
because, and
Cos
then
3x.
cos x cos 3x,
Cos x cancels.
on it becomes
Oh.
2 sine x by cos 3x.
Mm-hmm. Uh,
You understand what has happened?
yeah. Yes, I understand.
So basically, if I have to write the solution properly, I will just say multiply and divide by cos x.
Yeah.
Multiply and divide by cos x, so this becomes sine 2x, which can be written as sine 3x minus x, right?
Yes, I understand.
So every term here I will multiply and divide by cos 3x, and here I will
Yeah.
multiply and divide by cos 9x,
9x. Yeah.
right? So this will
Yes.
become sine of 6x, which is equal to 9x minus 3x, sine of.
Yes. Yes.
And that becomes, when you split it apart, it becomes tan 9x minus tan 3x. You understand?
1 second. From
I will
like
do it on a different.
the last step, we got 2 sin x by cos 3x, right? So
2
from
sin x
there,
by cos 3x, right?
so here, how to get in tan form?
So see, I will just multiply by cos x by cos 3x cos x. This becomes sine of 2x, right?
Yeah.
By cos 3x cos x. This becomes sine of 3x minus x by cos 3x cos x. That becomes sine 3x cos x minus cos 3x sin x
Yeah.
by cos 3x cos
Okay.
x.
So, okay. Now, yeah. Now I
Tan
get tan.
3x minus tan x. So same
Oh.
process you will do for all of them. So notice that earlier the question was looking like this, no, sine x by cos 3x plus
Yes.
sine 3x by cos 9x, and one more term is equal to 1 by 2 of tan 27x minus tan x, right? This was how
Yes.
the question was looking, okay? And
Yes.
why did I do this to this side is because I have some knowledge that, see, the last term had the 27, no, cos 27x,
I,
right? And
I,
it had a sine 9x or something, right?
yeah. Yes. Yes.
I have seen such questions before, in the sense that I know that if it is last term angle minus first term angle, then what about the middle terms and all? Those angles got cancelled, no?
Answer. Yes.
So 3 and 9, something has happened and they have disappeared, right?
Yes. Yes.
I ended up with angle here, the smallest angle and the largest angle, right?
Yeah. Yeah.
So something has disappeared. So this can only happen if each term is a difference of two terms and differences are such that these keep getting cancelled,
Yeah.
right? These right?
Yes.
This method is called method of differences. This method is called method of differences, where each term can be expressed as a sum of two terms with common one term which keeps getting cancelled in when you add so many factors, right?
Okay, fine. I understand.
So that is why I got the idea to split it like this, and then I multiplied by 2, and then I tried to prove that tan 3x minus tan x is equal to 2 sin x by cos 3x.
Yes.
Just to
Okay.
check my idea, and after that it was a straightforward thing. We just multiply and divide by, this is how you transform it,
Okay.
right?
Understood. Yes.
Okay, one last question.
Yeah. Um. Yeah. If A tan alpha
Hmm.
plus B tan beta
Hmm.
is equal to A plus B
Hmm.
into tan of alpha plus beta by 2,
Where a plus b is how? A plus b bracket.
A plus B in brackets
Hmm.
into tan of alpha plus beta by 2,
Hmm.
where alpha is not equal to beta.
Hmm.
Prove that A cos beta
Hmm.
equals to B cos alpha.
Okay, a cos
Yeah.
beta is equal to b cos alpha. Okay, so a sin alpha cos alpha. Okay. uh, hmm. So if you have to prove this, you can prove this instead,
Cos, yeah.
right? And if I have
Yes.
to prove this, instead of this I can prove cos alpha plus cos beta by cos alpha minus
Cos
cos beta is equal to a plus b by a minus b, right?
component.
Correct. So this I can prove this instead, and I'll get all of this, right? So I have to prove this. Let's think about proving this. So in this, let's simplify the LHS.
Okay.
LHS will be 2 cos alpha plus beta by 2 cos
Uh,
alpha minus beta by 2,
beta by 2.
and RHS will be 2 sine alpha plus beta by 2 into sine beta minus alpha by 2,
Yes.
right? So
Yes.
this becomes cos alpha plus beta by 2. So okay, this one is alpha minus
Um,
beta by 2 on top, and here also there is
so
an alpha minus beta on top, right?
if we take
I want to take
minus.
cot or tan. In terms of tan, I want to write it, right? So this is y tan alpha plus beta by 2, right? And
Okay.
1 by tan, this one,
Yeah.
and this one becomes minus 1 by,
Minus
or just
minus
minus
down
1 by
cot.
tan
No,
alpha minus
down.
beta by 2,
Yes.
right?
Yes.
Correct. This is my
Yes.
thing. So minus
Yeah.
1 by tan alpha by plus beta by 2 and tan alpha minus beta by 2 is, we have to prove that that is equal to a plus b by a minus b, right?
Yeah. Yeah.
Okay. Okay, so at least I have getting something here, something like this here, right? So
Yes.
tan alpha minus beta by 2 I need. So a tan alpha plus b tan beta by
Um,
tan alpha plus beta by 2 is equal to a plus b apparently.
plus. Yes.
So okay, so tan alpha plus beta by 2 is a tan alpha plus b tan beta by a plus b.
Hmm.
But how will I get a tan alpha minus beta by 2 also I need. So, oh wait, tan a plus tan b by tan a minus tan b is also something.
Tan A plus tan B by tan A.
Tan a plus
Um,
tan b into tan a minus tan b, right? That will be equal to sine square a minus sine square b by cos square A minus sin square B, right?
This is also an identity.
No, think about it. I'm just using the original two identities. You can write it as sin A plus B into sin A minus B, no? By cos A plus B into cos A minus B.
Oh, that's all. Okay, fine.
I've just written it like that, right?
Okay.
Correct. So instead
Yes,
of
yes.
worrying about this, I will just simplify it a little bit. Minus 1 by, this becomes A is alpha by 2, B is beta by 2, right? So sine square alpha by 2 minus sine square beta by 2 divided by cos square alpha by 2 minus sine square beta by 2.
Yes.
So this becomes sine square beta by 2 minus cos square alpha by 2 by sine square alpha by 2 minus sine square beta by 2,
Yeah.
right?
Yeah. Yes.
Okay, okay, okay. So this is now a little simpler, right? This one. This one is my this expression, right?
Yes.
So, okay. So now what? Now I have to prove that uh, it is equal to somehow a plus b by a minus b. So a plus b by a minus b I'll have to handle now. So I have still not thought of any nice way to use this. This is the problem. To use it somehow, right? So okay, I'll try it on the next page. A tan alpha plus b tan beta is a plus b tan alpha plus beta by 2. A tan alpha plus b tan beta is equal to a plus b tan alpha plus beta by 2. So maybe I've been doing it wrong. I'm complicating it too much. Maybe we should just do a tan alpha minus tan alpha plus beta by 2 is equal to b tan alpha plus beta by 2 minus tan beta, right?
Yeah.
Correct. So
Yes.
a
Yes.
by b is equal to tan alpha plus beta by 2 minus tan beta by tan alpha minus tan alpha plus
Answer.
beta by 2, right? So
Yes.
therefore it
Yes.
implies a plus b by a minus b is equal to, add it. So if you add it, it becomes tan alpha minus tan beta by, subtract it, you get 2 tan alpha plus beta by 2 and subtract it. So minus tan alpha minus tan beta, no?
Yes. Yeah.
Correct.
Yeah.
Now I have forgotten the second part of the question. What had we gotten there? What do you have to prove finally?
We have to prove A cos beta equals to B cos alpha.
E cos alpha, right? And we had deduced from there that a plus b by a minus b we have to prove is equal to what? 1 by
Cos
something.
1 by. Okay.
Just look at your notes. No, you made notes of the previous screen.
1 second. I wrote halfway.
Okay, wait. So a by b is equal to cos alpha by cos beta. So we did componendo and dividendo. So it is cos alpha plus cos beta by
Like I
cos
wrote till
alpha.
like cos alpha plus cos beta by cos alpha minus cos beta is A plus
Uh,
that
uh,
equals to A plus B by A minus B.
so instead of proving this, so we have to prove this, right? We already have
Yeah.
this much, right?
Yeah.
So almost there. So in terms of tan and all, instead of in doing in terms of tan and all, I will just do sine cos, I think, because that will give us some answers. So basically I have gotten a plus b by a minus b from here, no? So
Yes.
whatever this is, I have to prove that it is equal to this, right?
Yeah. Yeah.
Right. So uh, okay, I'll just simplify it. No, just simplify this denominator. 2 tan alpha plus beta by 2 is equal to 2 tan alpha by 2 plus tan beta by 2 by 1 minus tan alpha by 2 tan beta by 2, right?
Yes,
Minus
yes.
tan alpha minus tan beta.
Yeah.
Okay, this is a little annoying because it's so long and all, but wait, is there a smarter way to do it? Hmm. Hmm. Okay. Hmm. Maybe I should not have, no, I should have done this. A by B, can I do it directly from here or something? Hmm. Cos alpha by cos beta. Just, I don't want to do it. That is the problem. Sin alpha by cos alpha minus sin beta by cos beta. Sin alpha cos beta minus cos alpha sin beta. It is sin alpha minus beta by
Beta.
cos alpha cos beta. And this one becomes 2 sin alpha by 2 plus beta by 2 by cos alpha by 2 plus beta by 2 minus 2, this is minus tan sin alpha by cos alpha plus, so it becomes sin of alpha plus beta by cos alpha cos beta, right?
Yes, we got it.
So oh, nice. So this becomes 2 sin alpha by 2 into cos of alpha plus beta by 2, right?
Okay, that way. Yeah.
Right. So
Yes.
now this 2 sin alpha by 2 plus beta by 2 common. 2 sin alpha plus beta by 2 is common. It becomes 1 by cos alpha plus beta by 2 minus cos alpha plus beta by 2 by cos alpha cos beta.
Yes.
Cos alpha cos beta minus cos square alpha plus beta by 2, right?
Yes.
We have
Yes.
cos alpha cos beta minus cos square alpha plus beta by 2. This cos square alpha plus beta can be written as by 2 can be written as half plus cos alpha plus beta, right, by 2.
Yes. Okay,
Because
right.
cos square theta is 2 cos square theta is 1 plus cos 2 theta,
Yeah. Okay. Okay, sure.
right?
That way.
So cos square theta is half plus cos 2 theta by 2, no?
Yes. Understood.
So this is cos alpha cos beta minus half, so 2 cos alpha cos beta minus 1 minus cos alpha plus beta by 2, right?
Yes. Yes.
And in the denominator I have cos alpha cos beta into cos alpha plus beta by 2, right?
Mm.
So this becomes cos alpha minus beta, I think cos alpha minus beta minus 1. It is becoming very long and weird, but cos alpha minus beta minus 1 is coming. So, okay, I'm annoyed by this question, so I'll not do it right now. But try it no once. Try it from
Yes.
here. Try it from here and
Okay.
see if it matches. Okay.
Fine. I will
Uh,
try.
it is not difficult. It's just long and annoying. There may be some trick that I'm missing. I'm not sure. I have to check it again. Okay.
Okay. So I'll try.
Okay. So what I'll send is just message me and I'll send the trigonometric equations exercise 1 and all, and you can
This
start
recording, please share.
this
This
recording also I'll share, and just start working on the equations part also, the stuff that we did last class, no? Start working
Yeah.
on that equations part also, so that in
Oh,
next 2 or 3 classes we can finish the equations. So
okay.
after that what will happen is we'll do the properties of triangle chapter and all. the interesting
Okay.
bits. So far trigonometry is a collection of formula and ability to manipulate and handle stuff and do some crazy things, right? So
Yes.
when we come to the triangles chapter, it will be interesting. There you will learn like what is the geometrical aspect of it and how it is uh, going to be
Oh,
very imaginative questions can be solved. So it will be more interesting there. So
okay.
let's just try to finish in the next 2-3 classes the trigonometric equations part. Okay.
Okay. Yes.
Okay.
So when is the next class? This-
Now, like regular schedule, no? Wednesday, Friday, Saturday, right?
okay, fine. Same time. Okay, fine.
Yeah, yeah. Okay.
Okay. Thank you.
Okay.
Okay.
Bye.
Bye.